as I was saying, if they are charged or large molecules, like glucose is too large just to pass straight through the biolayer, and charged molecules would interact with the hydrophobic regions. So, for example, water would be attracted to the OH groups on the fatty acid tails. So that interaction there would slow the rate of diffusion down, which is why we need a specialised protein channel or protein carrier to help the diffusion take place. So there are two types of protein transporters that are used. We've got carrier proteins, which are here. So we've got carrier, and then here we've just got a channel protein. A carrier protein, then we can see that there is a higher concentration of this molecule here compared to here on the opposite side of the membrane. So this molecule would bind to the specific site. It would be a complementary shape to this protein. There'll be a receptor site, and once it's bound to the protein will change shape to facilitate the movement of the molecule to the other side of the membrane. So as you can see here, it would bind and be released here. And remember, this also does not involve ATP. This is a passive process. And once this has happened, protein will return to the original shape, back to that shape there. And then if we're looking at the channel proteins, this could be for, again, like a charged molecule, or we have more specialised channel proteins for water, which are called aquaporins, which are specialised for water to move through the membrane easily without having to interact with the hydrophobic regions of the phospholipids. And we can see here that there's a higher concentration of this molecule if it's water, and then it would just diffuse straight through. So with these, we've got cholesterol molecules, which will restrict the size of the channel protein, so that only certain molecules can diffuse through. So it will restrict the diameter of the protein channel. So this is why you wouldn't get glucose diffusing through here, because it would be too large even to pass through these channel proteins. Some channels can be gated, so they'll need, for example, if it was calcium ion gated channels on collagenic synapse, then we would need calcium to bind to the channel in order for it to open and let anything else through. If we're talking about aquaporins, then these are slightly more specialised. In an aquaporin, we only have one molecule, should be one water molecule, going through at a time. and these molecules would flip as they're going through. So they flip, similar to this, so they turn the other way around. It is, remember, there's no ATP being used, it is passive. Yep. And that is just a brief overview of both types. Remember, they both do not use ATP. If it does use ATP, that'd be active transport. And yeah, thank you for watching.